Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Solving Inequalities and Graphing Their Solutions. So you will notice on these problems, the variable is definitely not by itself, and so we have to ask ourselves what's happening to the variable. We can see here it's being added by 62, and so we're going to subtract by 62 on both sides. 54 take away 62 will give us negative 8. 62 minus 62 is 0, so that leaves us with the y by itself. And that is the first part of the directions where we are solving the inequality using inverse operations. So we have the solution here. Y is greater than negative 8. The next part, though, according to the directions, is to graph the solution on a number line. And so traditionally, we're going to put 3 hash marks on that number line. Now we need to remember, since the solution here of y is greater than negative 8 has the negative 8, that's a negative number, you need to remember that negatives go in reverse order from positives. So when you set up the labeling of your hash marks, the negative 8 traditionally goes in the middle, but you need to know that negative 9 would be to the left of negative 8 and negative 7 would be to the right of the negative 8. And that has nothing to do with the inequality symbol. It has everything to do that is just the order that negative numbers always go in. Okay, they're always reverse order from positives. So now on the number line, we need to figure out which way will we graph. Well, since the problem tells us that y is greater than the negative 8, you have to think to yourself, where would the greater numbers be on the number line from the negative 8? Well, it would be things like negative 7, negative 6, and negative 5, and working your whole way to 0, and then positives. All those numbers are bigger than negative 8. And since the solution is y is greater than negative 8, then that is why we must shade in that direction. Now you will notice that I have an open circle at the starting point. The reason why it's an open circle is because if y is greater than negative 8, then it cannot equal the negative 8. The only way it could equal the negative 8 is if there was a bar underneath the greater than symbol, then that would mean or equal to. But since number 1 did not have that, then we leave the starting point as an open circle to show that the y cannot equal the negative 8. Okay, so that was problem number 1. Problem number 2, we would ask ourselves what's happening to the variable. Obviously, the variable you can see is being subtracted by 91. So we're going to do the inverse, which is to add by 91 on both sides. The right side, if you made subtraction adding the opposite, you would have negative 91 plus 91, which just gives you the m by itself. The left-hand side, you would subtract in your head or maybe off to the side or maybe even use a calculator. That's going to give you positive 12. Now here's the deal. Notice how in number 2, after I solve, the variable is on the right-hand side. Now that is actually very problematic for most students because we have to graph. And you're probably looking at this problem and you're seeing the greater than or equal to symbol. And we just said how in number 1, if it's greater than, we're shading to the right. That's what we were just saying. And so number 2, you might think, well, it's greater than or equal to, so again, we're going to shade to the right. No, we're not. Why not? Why is this different? It's because the variable is not written first. When I say first, I mean on the left side of the inequality symbol. Instead of the variable being there, we have the number there. So why does that matter? Well, if you check out this information box off to the side, you will see that since we always read left to right, the final answer makes a lot more sense when it begins with the variable. When I say begins with the variable, I mean the variable is written to the left of the inequality symbol. So whenever you get a problem like number 2, that after you've solved it, the variable ends up being on the right side of the inequality symbol, the best thing for you to do is to flip the whole thing around. So that way you can correctly interpret what this answer means. Here's what I'm trying to tell you. If 12 is greater than or equal to m, then that means that m is less than or equal to 12. And that is why your graph is shading to the left. Because if m is less than or equal to the 12, then that would be numbers like 11 or 10 or 9 and so on to the left of the 12. I am telling you right now, ladies and gentlemen, students who do not make sure that their final answer has the variable first, they tend to accidentally graph the wrong way, meaning they accidentally shade in the actual opposite direction of where they're supposed to be shading. And this is why I gave this recommendation over here on the right side. You might want to star that in your notes. It's very important that your final answer has the variable first, meaning to the left, the inequality symbol. That's the easiest way to be able to interpret your answer, and not just for the purpose of graphing, but it definitely helps with graphing. All right, so now that we've talked about numbers 1 and 2, let's skip the rest of the second page for now, or sorry, the rest of the first page for now, and let's skip to the second page. And on the second page, you will see we have the same kind of directions. We're going to solve the inequality, and then we're going to graph its solution on a number line. And I did not make the number lines for you. You're going to have to create them on your own. Let's skip number 1 for now because it has decimals, and I have not taught you yet what we're going to do when the solution has a decimal. We'll get to that soon. But right now, I want you to try number 2 and number 3 on your own based on what I was just talking about from the top of the first page. You can go back to that and use that as a guide if you need to. So hit pause on the video, do numbers 2 and 3 on your own right now, and then hit play when you're ready to see how you did. Okay, I hope you already did number 2 and 3 on your own. Let's go ahead and see how you did. Number 2, since the r is being added by -17, you could subtract by -17. Now, I bet some of you realize, well, you could also just add the opposite right away and make it adding by a +17. So that way, -17 plus +17 would give you 0, which would leave you with the r by itself. And I know some of you are able to figure out that you would add by a positive right away instead of writing minus a negative, and so that's fine. I definitely would never keep minus a negative as looking as minus a negative. Always make that become adding a positive before you finish the problem. All right, on the right-hand side, you're going to get -97 plus 17. You're going to subtract in your head. That's going to give you -82. So this should have been your solution. R is less than -82. Make sure you have a less than symbol here and not accidentally putting an equal sign. I know, old habits. We spent so many weeks solving equations. You're probably very used to putting an equal sign there. So let's be very careful about that. Now, you needed to graph the solution on a number line. Did you remember to do that? If not, you might need to hit pause on the video and quickly put the graphs for numbers 2 and 3. All right, hopefully you did that if you needed to. Now, notice your negative numbers. Negative numbers go in reverse order from positives. So that's why -83 is to the left of -82 and -81 is to the right of -82. So on your number line, we now have to figure out, okay, which way are we going to shade, left or right, and will we start with an open circle or will we start with a filled in dot? And so here's the deal. Number 2, it says that r is less than -82. If it's less than the number, then we will go to the left because that's where the lesser numbers are, the smaller numbers. They're always to the left if it's less than. But we have to figure out, are we going to start with an open circle or a closed filled in dot? Since this answer does not have the equal to bar underneath, it did not have the equal to bar, then we cannot fill in the circle. We have to show that it cannot equal the starting number, and that's why we're going to start with an open circle. By the way, I forgot to mention on the first page, the reason why we had a closed filled in dot on number 2, forgive me for forgetting to mention this, but it's because the inequality symbol had the equal to part underneath the less than symbol. So it was less than or equal to. When it can equal the starting number, that's when you're going to start with a filled in dot. Now, with that in mind, let's take a look at problem number 3. So what was happening to the variable? It was being subtracted by -35. Therefore, you could add by -35 now. You could also make the original problem become adding the opposite, and then maybe you would have subtracted by 35 on both sides, but that means the same thing as adding by negative 35 on both sides. So either way, it's going to work, and you will get negative 24 is greater than or equal to x. Now, did you remember the advice I gave you on the first page? We do not want to have the variable on the right-hand side. We do not. Because I'm telling you, kids who leave the variable on that side, most of the time they end up graphing the wrong way because they don't even really know what their answer means. It's important to me that you know what this answer means. So here's what it means. If negative 24 is greater than or equal to x, then that means the x is less than or equal to the negative 24. And I want you to write it that way. I'll tell you, on the upcoming test we're going to have, the multiple choice answers will have the variable written first at the beginning, to the left in the inequality symbol. You need to make sure your final answers for algebraic inequalities have the variable written first over on the left. Now we can interpret the problem. X is less than or equal to the negative 24. So we set up our skeleton number line. We're going to put negative 24 in the middle. Remember, negatives go in opposite order of positives. That's why negative 25 is to the left and negative 23 is to the right. Since x is less than or equal to negative 24, we are going to shade to the left, just like on number 2. But unlike number 2, we're going to start with a closed filled-in dot. Why? Because this inequality symbol was less than or equal to. That bar means it can equal the starting number. And if it can equal the starting number, then we will put a filled-in dot at that place. So that's why number 2 had an open circle, but number 3 had the filled-in dot. All right, now that we have done number 2 and 3 together, let's go back to the first page. And I want to talk about the very bottom, because this is kind of like what we were doing, except now there's decimals involved. So number 7, and this is already typed up for you in your guided notes, you would do the inverse of subtraction, which is adding. And so, that's going to give you r is less than or equal to 15.2. Doesn't seem like a big deal, right? But we're going to have to graph. And traditionally, we count by ones on our graphs, right? Like you saw here on numbers 2 and 3, we counted by ones. But that's when our answers didn't have any decimal or fraction pieces to them. That's when the answer was just like r is less than an integer, or x is less than or equal to an integer. No fractions or decimals existed. Well, this is different on number 7 at the bottom of the first page. It's 15.2. R is less than or equal to 15.2. So here's what we're going to do. We're going to create just 2 hash marks on our number line, and we're going to label them with whole numbers. And so we just have to ask ourselves, what 2 integers, or in this case, since it's positive, what 2 whole numbers is that 15.2 in between? Hopefully you have good number sense and you realize that 15 and 2/10 is in between the whole numbers of 15 and 16. Now, since it's only 15 and 2/10, then it's definitely going to be closer to the 15 than it would be to the 16. And so what we do is on our 2 hash marks, we label the 2 whole numbers that the 15.2 is in between. We're not going to put decimals on our hash marks. We're going to put integers. That's what the note says up here in this box, that number lines traditionally use integers. I'm talking about numbers that do not include decimals or fractions. So back to number 7's graph. The 2 integers are 15 and 16. That is what 15.2 is in between. And then we just got to put the dot at the correct place. Like I said, since the 15 is closer, the 15.2 is closer to the 15, that's why the dot was pretty close to the hash mark that was labeled 15. And then since it was less than or equal to the 15.2, that's why we're shading to the left. Let's look at another example, number 8. So the inverse of adding by 53.1 is subtracting by 53.1. If you want to make that add in the opposite, you can. I really don't care quite as much. at this point, because I know a lot of you are probably going to be using your calculators on some of these problems, but you could make this add in the opposite if you so desire. And so a negative plus a negative, you'll add in your head, get negative 56.8. Now this one was a little bit different. You will notice the variable was not the beginning of the answer. It was over on the right-hand side instead. And so we're just going to switch the order so the variable is written first, like I was telling you guys before. And so here's our solution. W is greater than or equal to negative 56.8. But again, there's a decimal part to this. And traditionally, we are going to use integers on our hash mark. So we have to ask ourselves, what two integers is this negative 56.8 in between? Well, it would be in between negative 57 and negative 56. Now, notice the order I wrote that in. I put the negative 57 first because negatives go in reverse order from positives. Since it's negative 56 and 8/10, that makes it closer to the negative 57 than it would be to the negative 56. So we're going to label the two hash marks with negative 57 and negative 56. Since negative 56.8 is closer to that negative 57, then that's where our dot will be, closer to the negative 57. And then since our solution was that W is greater than or equal to the number, then that's why we're going to the right. That's where the greater numbers would be. All right, so now that I've talked you through number 7 and 8, let's go back to the first page. Remember we had skipped number 1. It's time for you to go ahead and try that problem on your own. Hit pause in the video, do number 1 on your own, and then hit play when you're ready to see how you did. Okay, so problem number 1. Since it's being added by 49.4, you're going to subtract by 49.4 on both sides. If you want to make subtraction add in the opposite, that is fine with me. A negative plus a negative, you would add in your head. You could probably do this without a calculator. That's going to give you, what, a 0.8, and then 1 and 9 makes 10. You'd carry the 1. So that would give you negative 70.8. And so W is greater than or equal to negative 70.8. The variable is already written first, which is nice. That's where we want it to be. And so how do we do this? Well, we got to ask ourselves, what two integers is this negative 70.8 in between? Because you're only going to put two hash marks, because we're only going to use integers underneath our hash marks. We're not going to put decimals as the labels under our hash marks. So what two integers is negative 70.8 in between? It is in between negative 71 and negative 70. Who is it closer to? Well, since it's negative 70 at 8/10, that is going to be closer to the negative 71. So you kind of have to guesstimate where that dot's going to go. Definitely closer to the negative 71. And since it says that W is greater than or equal to the number, the greater numbers are always going to be to the right. And that's why you're going to be shading to the right. Oh, by the way, since it was greater than or equal to, the equal to part is why we are putting a closed filled-in dot instead of leaving it as an open circle. And that's how problem number 1 works. All right, let's go back to the first page again. We had skipped the middle section where problems 3, 4, 5, and 6 were shown. And there was a very important rule to know that I definitely want you to end up memorizing. This is an extremely important rule. It is not going to go away. You're going to need to know it in Algebra 1 as well. Follow along with me. It says when multiplying or dividing both sides of an inequality by a negative number, the inequality symbol switches direction. All right, so when does it switch direction? When you're multiplying or dividing both sides by a negative number. So take a look at number 3. The variable is being multiplied by negative 25, so you would divide by negative 25 on both sides. Since we are dividing by a negative on both sides, then the rule to know applies, because it says when you're multiplying or dividing, and here we are, by a negative, here we are on both sides, then the inequality symbol will switch directions. So what do I mean by that? Well, the inequality symbol used to be greater than or equal to. But since we are dividing by a negative on both sides, that will make it switch direction, and it becomes less than or equal to. Same thing's going to happen on number 4. The variable w is being divided by -6. That's what that fraction means. And therefore, we would do the inverse, which is to multiply by -6 on both sides. And again, notice we are multiplying by a negative on both sides. That's what the rule to know is saying. When you multiply or divide both sides by a negative, that's what we're doing here on number 4, then the inequality symbol switches direction. So the inequality symbol used to be less than, but since we multiplied by a negative on both sides, it changes to the greater than symbol. It switched its direction. So that's 2 examples of the rule to know being applied. But notice I labeled number 5 and 6 as counterexamples. On number 5, you divide by a positive on both sides. Does the inequality symbol switch direction? No. Number 6, I would subtract by 18 on both sides, which is the same as adding by -18 on both sides. Does the inequality symbol switch direction? No. So the million-dollar question of the day, why did the inequality symbol switch on numbers 3 and 4? But for some reason, the work we did on 5 and 6 did not make the inequality symbol switch. Do you know why? Hit pause in the video. Write down a sentence explaining why the inequality symbol switched on 3 and 4 but did not switch on 5 and 6. Then hit play when you're ready to see how you did. Okay, I hope you already answered this question. The reason why that it switched on numbers 3 and 4 is because we were actually multiplying or dividing by a negative on both sides, which is what the rule of this day is saying, okay? Multiplying or dividing both sides by a negative. We actually are doing what the rule says, and so that's why the inequality symbol switches direction. But on number 5, were we multiplying or dividing by a negative? No, we were dividing by a positive. Well, number 6, we were doing a negative, but were we multiplying or dividing by it? Oh, no, we were adding. And so the moral of the story is the inequality symbol only switches. It switches only when you multiply or divide both sides by a negative number. Number 5, we were dividing by a positive. That's why the inequality symbol didn't switch on number 5. Number 6, we were adding by a negative. Well, that's why the inequality symbol didn't switch on number 6. It only switches when you multiply or divide both sides by a negative number. Let's see if you can apply this rule. This is a brand new rule. I know you never learned this before. Let's go to the second page. We already did 1, 2, and 3. Let's now have you do 4, 5, 6, 7, and then you'll eventually also do number 8. I'm going to do number 4 with you. So here we go. What's happening to the variable in number 4? Well, it's being multiplied by -5. The inverse would be to divide by -5. That's going to give you a -33, and you'll get the q by itself on the left. Now, will this make the inequality symbol switch direction? What do we do again on both sides? We divided by a negative. Is that the type of thing that makes the inequality symbol switch direction? Yes, that's exactly the type of thing that makes the inequality symbol switch direction. So, since we divided by a negative, boom, the inequality symbol switches. It used to be greater than, now it is less than. And so now we're going to label our 3 hash marks. Notice negative numbers go in opposite order from positives. And since it is q is less than the -33, then we need a shade to the left. Since the inequality symbol did not have the equal to bar underneath, it did not have it, then we leave the circle open at that starting point. Okay, I've done number 4 for you. That was an example of where we did multiply or divide by a negative on both sides, and that is what made the inequality symbol switch direction. Let's have you hit pause on the video. I want you to do number 5, 6, and 7, those 3 problems, 5, 6, and 7 on your own, then hit play when you're ready to see how you did. Okay, I hope you already did 5, 6, and 7 on your own. Let's see how you did. Number 5, since the variable was being divided by the negative 14, we're going to do the inverse, which is to multiply by negative 14. So that's going to give you positive 98 because a negative times a negative is a positive. Will this make the inequality symbol switch direction? Well, we are multiplying by a negative on both sides, and the rule that we were talking about in the middle on the first page does say when you multiply or divide both sides by a negative that the inequality symbol will switch direction. And so that's what we did on number 5, and therefore the inequality symbol will switch direction. Now, if you forgot to switch the direction of the inequality symbol, then you're going to end up graphing the wrong way, and you're going to need to hit pause in the video again and fix your work. We are going to need to have a closed filled in dot at 98 because it had the equal to part on the inequality symbol, and then we're going to shade to the right because the x was greater than or equal to the 98, and that would take you to the right of the 98. Problem number 6, the inverse would be to multiply because it already was being divided on the original equation. So we're going to multiply by 12 on both sides. That's going to give you negative 74.4. Now, will that make the inequality symbol switch direction? Well, let me ask you, were we multiplying or dividing by a negative on both sides? No. We were multiplying by a positive on both sides. That does not make the inequality symbol switch direction. It only would if you were multiplying or dividing by a negative, and here we are not. So the inequality symbol stays the way it was. Your graph should have only 2 integers under the hash marks because this has a decimal part to it. So you have to ask yourself, what is negative 74.4 in between? It is in between negative 75 and negative 74. It's a little bit closer to the negative 74. It's almost at the halfway point because the halfway point would be the 0.5 mark. So it's a little closer to the negative 74. Since k is less than the number, that's why we're shading to the left. Problem number 11, the inverse of multiplying by 11. Did I just say problem number 11? Problem number 7. The inverse of multiplying by 11 is dividing by 11. We're going to do that to both sides. That's going to give you negative 22. Will it make the inequality symbol switch direction? Well, let me ask you, did we multiply or divide by a negative? We divided by a positive. So the inequality symbol does not switch direction from dividing by a positive. But having said that, is the variable at the place that it should be so you could correctly interpret the answer and then correctly graph the right way? No. So you should have done an extra step. Since the variable was not written first, you should have flipped the entire thing around. If negative 22 is greater than or equal to w, then w is less than or equal to the negative 22. You label your 3 hash marks. Again, negative numbers. I've given you a lot of answers with negative numbers. They're going to go in reverse order from positives. You're going to have a closed filled in dot shaded to the left. It's closed filled in because it had the equal to part, and we're shading to the left because the w is less than or equal to the number, and so that's why we go to the left. All right, there are 3 more problems to go, number 8, 9, and 10. Now, I will warn you, little friendly reminder, number 9 has 2 things happening to the variable. So you're going to need to do an inverse operation on both sides and then later do another inverse operation on both sides later in your work. Hopefully you remember what order to do those inverse operations in based on what I've taught you from previous lessons from solving equations that had 2 things happening to the variable. So please do not forget how that works. So hit pause on the video, do 8, 9, and 10, then hit play when you're ready to see how you did. All right, let's check to see how you did. I assume you already did 8, 9, and 10. If not, you better hit pause now. Number 8, since the variable was being multiplied by negative 5 sevenths, you're going to divide by negative 5 sevenths. That's going to give you negative 9 and 1/3. Now, will this make the inequality symbol switch direction? The answer is yes, because you are dividing by a negative on both sides. So boom, the inequality symbol must switch direction. Since the answer has a mixed number piece, then we have to figure out that this is in between negative 10 and negative 9. It's going to be a little bit closer to the -9, and you're going to shade to the right since m is greater than the number. And notice it's an open circle on the graph because this inequality symbol did not have the or equal to bar underneath it. Problem number 9, we are going to start this problem by doing the inverse of the last thing that was happening to the variable, which was the subtracting by 6. Remember, inverse operations go in the opposite order from what was happening to the variable. So we're going to do the inverse of subtracting by 6 first, which is adding by 6. Adding and subtracting will never make the inequality symbol switch direction. Only multiplying or dividing by a negative would it make the inequality symbol switch direction. So we add by 6 on both sides, we get -16, and then n over 8 by itself on the right. The inverse of dividing by 8 is multiplying by 8. That is going to give you -128 on the left. Now, does multiplying by a positive on both sides, does that make the inequality symbol switch direction? No, it does not. So the less than or equal to is still less than or equal to. But having said that, is the variable at the location that we want it to be? No. So you should go an extra step. Flip the entire thing around. Because if -128 is less than or equal to the n, then that means n is greater than or equal to the -128. And that is why your graph would be shading to the right. Because the n is greater than or equal to the -128. And when it's greater than the number, we're going to go to the right. Since it has the equal to part, that's why we put a closed filled-in dot at the starting point. Last problem, number 10. Again, we're going to do the inverse of the last thing that was happening to the variable. We're going to do that as our first inverse operation. So the inverse of adding by 58 is to subtract by 58. That will give you -46. Left-hand side will give you -6y. Adding or subtracting will not make the inequality symbol switch direction. It will not. But dividing by a negative on both sides, which is what we're doing, that will make the inequality symbol switch direction. Did you remember to do that when you divided by -6? If not, fix it. Hit pause if you have to. Now notice this answer has a decimal piece to it. So again, what two integers is 7.6 repeating in between? It is in between 7 and 8. It's going to be closer to the 8. And so you're going to have an open circle closer to the 8, shaded to the left. Because if y is less than the number, then we are going to the left of that number on the number line. And that concludes the guided notes on solving inequalities and graphing their solutions. Thank you for watching. We'll see you next time.